So we have to integrate x raised to power 4 over 1 minus x squared with respect to x. So we know that 1 minus x squared, which is the denominator, is less than the numerator, which is x raised to power 4. So we are going to use the long division method for polynomial to divide these fractions to get the components that are in it. So we place the dividend inside the division sign and we place the divisor outside. Now, to divide this, we need to divide the dividend, which is x raised to power 4, with the value of x that have the highest power, and that is minus x squared. So when you divide x raised to power 4 by this, you are left with minus x squared. So this is the first term of our quotient. Okay, so this is the first term for our quotient. So we repeat this same process until we have a remainder. So we're going to multiply minus x squared by the divisor, and that will give us x raised to power 4 minus x squared. Okay, so that will give us x raised to power 4 minus x squared. So after that, we subtract this from the divisor, and when we subtract, we are left with x raised to power 2. So we repeat the process. We divide x raised to power 2 by the highest power of x, which is x squared. So if we should do that, we are left with minus 1. Then we multiply minus 1 by the divisor again, and we are left with x squared minus 1. So when you subtract, we are left with a remainder, which is 1. And after doing this, we know that the dividend, which is x raised to power 4, must be equal to the divisor multiplied by the quotient, and then we add the remainder to it. So everything on the right hand side is equal to the left hand side. So this is a basic rule and it is proven. Okay, so now let's erase the bracket and let's rewrite the integral by replacing the x raised to power 4 with the divisor, quotient, and remainder. So that's what we are doing now. So that gives us 1 minus x squared multiplied by minus x squared minus 1 plus 1 over 1 minus x squared. So, and the integral sign and what you are differentiating with, which is the x. Okay, so that's on the board. So let's clear this also so that we can have space for the next work. Okay, let's zoom in. Okay, so yeah, let's zoom in. So there's enough space for us to work now. So after doing this, so we need to split this fraction into its part, because there's a positive sign, there's a plus sign between the two numerators, so we can split this fraction into parts, and the initial part is going to be 1 minus x squared multiplied by minus x squared minus 1 everything over x squared. So that's the first part when we split this fraction. Okay, 1 minus x squared, then plus minus 1 minus x squared, sorry there. So I've split this fraction into this part. So 1 minus x squared cancel out 1 minus x squared at the first term of the integral stuff, so it cancels out. So we are left with the integral of minus x squared minus 1, right? So that's what we are left with after we cancel out 1 minus x squared. So okay, sorry here, I'm trying to navigate the buttons over there. Okay, so now we are left with minus x squared minus 1, the integral, plus 1 over 1 minus x squared dx. So the very first two terms are easy to solve now, because we know that if we should integrate minus x squared, we know the integral of that. I know the integral of minus 1. So let's just integrate those two first before we proceed to integrate 1 minus x squared. Okay, so now looking at 1 over 1 minus x squared, we know that it is a 1 over 1 minus x squared. Denominator is difference of 2 square, so we split it into its component, which is 1 plus x and 1 minus x. So if we should use the principle of partial fraction, which I'm not going to explain in this video, maybe some other video I'm going to explain partial fraction. So after splitting it, we are left with a over 1 plus x plus b over 1 minus x. And when we solve for a and b, we are left with a is equals to half and b2 is equals to half. So we rewrite 1 over 1 minus x squared as 1 over 2. Okay, so 1 over 2 into brackets 1 plus x bracket close plus 1 over 2 into brackets 1 minus x. Okay, so the 1 minus x is with the 2 is not multiplied, it is 2 multiplied by into bracket 1 minus x over there. Okay, so let's zoom in again so that I can have enough space to continue the work. So after splitting the 1 over 1 minus x squared into this, then the work is easier. So our final answer is going to look like this. Okay, minus x cubed over 3, because if you should integrate minus x squared, you are left with minus x cubed over 3. And if you should integrate minus 1, you are going to have minus x, because minus 1 is a constant. Now, integral of plus the integral of, okay, 1 over 2 into bracket 1 plus x, okay, plus 1 over 2 into bracket 1 minus x. Sorry, so the 1 minus x should be with the 2 over there. Okay, so that's about that x. Okay, so let's zoom in again so there will be a space for the final answer. Okay, so yeah, so now the final answer looks like this. So minus x cubed over 3 minus x plus, now if you integrate 1 over 2 plus 1 plus x. 1 over 2 is a constant, so we don't work with that, just put it down 1 over 2. So the integral of 1 over 1 plus x is ln 1 plus x. That is the standard form of integral. So that gives us 1 over 2 ln 1 plus x. The same thing applies to the second part of the stuff. That gives us 1 over 2 ln 1 minus x. So I'm going to explain in some other video why 1 over 1 plus x gives us ln 1 plus x. But for now, just know that 1 over 1 plus x is ln 1 plus x, where ln is log to the base of e, and e is an exponential function. Okay, so this is our final answer here. So see you in the next video. Bye bye.